The original Superboard came with an interface for loading and saving programs. It was a cassette recorder interface. The BASIC and ROM that was built on the card had two commands which supported saving and loading programs. The user manual defines load, or describes it as accepts input from cassette tape and puts it into source memory. To exit from the load, hit a space or spacebar. Even though I'm very fond of retro computers, I'm not going to go down this route. Basic manual for save says this slows down the cycle of displaying input to the screen so that when followed by list, the speed is appropriate for writing to a tape. The information is also sent to the tape port. Exit from the save mode by doing load, return, spacebar. The procedure for saving basic programs to tape is save, return, list, start tape, wait for a few seconds to give it a leader, then return. The Cyclone 4 board has a USB to serial interface on it so we can emulate the tape interface. To do this, I launch PuTTY on my computer and hook up to the card. Here I'm running PuTTY on the computer that's attached to the USB port, and when I open PuTTY, I'm going to also resize the window to make the text bigger and clearer to read. 24 points should be plenty good enough for what we're doing here for this example. At this point, you're ready to go over to the Superboard side and do load. And if you copy a program on the Windows side in and right paste it with your mouse, it'll drop it into that serial connection up to the Superboard card. When I first tried this at 9600 baud, things did not go well. As you can see, the screen is dropping a lot of characters and there's a lot of syntax errors. That's partly because the original cassette interface was 300 baud, and partly because of the way that this card implements the serial port. After changing the VHDL code for the baud rate generator to create 300 baud, the serial port started working just fine with no drop data. If you want to skip forward past the loading of the data to the loading of the machine code, the time will be presented on the screen here. This program consists of two pieces. One is a basic program, which is, I think, pretty much a loader, and the second part of the program is machine code that's made to run much more efficiently. The particular program we're loading here is Asteroids, or as it says on the screen, I believe, Asteroid. After loading the basic code, the machine then loads the machine code. You should be able to skip forward and if you don't want to watch the whole load, but basically it shows itself on top of each other on the screen here. And each of those are addresses at the beginning followed by data, which is the actual program. It's a much more efficient program being written in machine code than it is if it would be written in BASIC. The program automatically runs it after it finishes loading and asks if you have a sound card. Well, I don't have a sound card, but here it is. It's the little arrow in the middle of the screen. Not quite familiar with what the keys are. It's been many, many years since I played this, but I remember the space bar was the shoot. One of the interesting things to see on the screen here is the fact that we've upped the screen resolution in the previous video to 64 columns and 32 rows, but this original game would have been written for the machine as it shipped. So the pieces off the left and the right hand side are the extra sides of things that aren't on the screen. Here's the buttons that you press on the screen to fire and rotate. There's a clue in Grant's original circuit that explains why it does not work at 9600 baud in this particular instance with this FPGA card, and that is because Grant has a request to send signal that tells that the buffer inside of the OSI card, the OSI software buffer, is full, and it will automatically tell the FTDI interface to stop sending data, which handshakes back up to the computer and it stops sending data. In contrast, the FPGA card is hooked up a little bit differently. Although they have RTS, CTS, all the handshake lines on the chip, the only two pins that they bring over to the FPGA are the transmit and receive. Hence, there's no support for hardware handshake, and the baud rate has to be limited down probably close to 300. I haven't done any regression testing to see how much quicker it can go. It probably can go quicker than 300 because the processor is obviously faster here, but 9600 baud was enough that it was dropping a lot of data. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindie where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.